Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. The horizontal component of velocity of the projectile will remain constant throughout its motion. Based on this, we can expect several tricky questions. But as long as you are conscious and aware of the fact that the horizontal component of velocity of projectile remains constant, you can solve the questions very easily. I will give you a couple of examples on that. Look at this question. Find the speed of the projectile u comma theta, that is, speed is u projected at an angle of projection theta, when its velocity vector makes angle theta by 2 with the horizontal. So draw the figure. This is projectile. Let me draw it neatly. Yeah. So coordinate axis. Yeah. This is the projectile. Initially, it has got certain velocity u. The angle of projection is theta. The horizontal component of velocity is u cos theta. I am not bothered about the vertical component. It goes on decreasing. At the maximum height, there is only horizontal component, but the vertical component has become 0. The angle that the velocity vector is making with the horizontal at the maximum height is 0. So the projectile's velocity vector makes angle theta initially, and that goes on decreasing while the projectile reaches maximum height, and finally it becomes 0. Then it starts increasing in the opposite direction. So there is one point during its ascent where the velocity is v, the magnitude of velocity is v, and it makes angle theta by 2 with the horizontal, half of the angle of projection. The question is, find that v, the magnitude of velocity. Find the speed of the projectile when its velocity vector makes an angle theta by 2 with the horizontal. The first step is understanding the question. Now the second step, applying the right concept. And projectile horizontal component does not change. Let me assume the speed at this point be v. Then the horizontal component of its velocity becomes v cos theta by 2. So one single step, equating horizontal component initially to horizontal component at that instant, v cos theta by 2. V is equal to u cos theta by cos of theta by 2. As simple as this, just 2 steps, you got the answer. Very simple application of the concept. Let me give you another example. Find the speed of the projectile u comma theta when its velocity vector makes angle 90 degrees with the initial velocity. Draw the figure again. Take coordinate axis. Yeah. And consider a projectile like this. Yes. Now, initial velocity of the projectile is u at an angle theta with the horizontal. During its trajectory, so this is the direction of initial velocity, you are supposed to find the velocity, the magnitude of velocity or the speed of the projectile when its velocity vector is perpendicular to initial velocity. That is only possible somewhere here. Say it has got velocity v. If you extend this, you can see that the direction of velocity v is perpendicular to the initial velocity's direction. At this instant, you are supposed to find the speed. Now, if you apply equations of motion and do a lot of math, it is just waste of time. Just simple logic is expected here. Consider the directions. This is u, initial velocity making theta with horizontal. This is v at some instant, which is perpendicular to initial velocity. So angle that it makes with horizontal is 90 minus theta, 90 degrees minus theta. Now you have to equate the horizontal component of these two velocities. Horizontal component of initial velocity is u cos theta. Horizontal component at that instant where velocity vector is perpendicular to initial velocity is v cos 90 minus theta. So u cos theta is equal to v cos 90 minus theta, that is sin theta. So v is equal to u cot theta. That's all. This is the answer. The speed of the projectile when its velocity vector makes angle 90 degrees with the initial velocity's direction, that is u cot theta. Very simple, isn't it? So you can apply concepts like this in many problems once you have that conceptual clarity and arrive at the answer in the most simple possible way. Isn't it simple? Now I'll give you a question to solve. Say there is a projectile u comma theta, so consider this case. During its trajectory, it reaches a point where the velocity vector makes angle theta by 2 with the horizontal. We found the speed there. Now the question is, find the radius of curvature of the projectile at this point where the velocity vector makes angle theta by 2 with the horizontal. I repeat the question, find the radius of curvature of the projectile at that point where the velocity vector makes angle theta by 2 with the horizontal. So try this question and you can post your solutions in the comment section. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.